Hello, good morning to everyone. I hope you all are fine. Today we are going to study about Ohm's law, resistance and combination of resistors. Let us start our topic, Ohm's law. A scientist called George Simon Ohm, he established the relation between current and potential difference. He found that current flowing through the wire is directly proportional to the potential difference if the physical conditions are maintained constant. Try to understand like this. Suppose there is one cell we have connected here. This cell will supply energy and the work will be done as the charge will flow in the circuit. When the charge will flow in the circuit, suppose here I have kept here bulb or fan or anything here, and I am joining these two terminal of the cell with one circuit here. Then and this cell will provide energy to the charge to move, and when the charge will move, they will do some work. Then if we increase the number of cell, the energy supplied by the cell will increase. Simply we can say EMF will increase. That will also increase the potential difference. About EMF and potential difference, we have studied in the previous video. Those who have any problem, you can see over there. Then according to the George Simon Ohm, if we go on increasing the number of cell in this circuit, then the value of current flowing through this wire will also increase. He have established the relation that suppose we are drawing one graph here, here potential difference and here electric current. Suppose we are putting the value of potential difference this much, then the value of current will be like this, like if we are increasing the value of potential difference, the value of current will also increase. And when we will plot the graph for this, suppose this and these 2 points, graph point will be here, this and this current and potential difference graph will be here. If we are again increasing the value of potential difference, again the value of current will increase. Suppose this and this point it's coinciding here, and if we are drawing a graph, it will come like this. This indicates that if we go on increasing the potential difference, the value of current is going to increase. And this is the Ohm's law. And again I want to repeat the statement. Ohm's law states that the current flowing through the wire is directly proportional to the potential difference. If we go on increasing the cell, the value of current flowing through the wire remains and go on increasing. Okay. If the physical conditions are constant, physical conditions means if we are keeping the same wire of same thickness, same length, we are not changing the wire, then if we are going to add here cell, if we are increasing the potential difference, then the value of current will go on increasing. This is the Ohm's law. I hope you understood this. Now we go to the, like this, we have to, from this Ohm law, we can also write this V proportional to I. If V is increasing, I will increase. If I is increasing, V definitely has increased. If we are removing this proportional sign, then V is equal to Ri, and this can also be written like this: V is equal to I R. This is one formula that we derive from the Ohm's law. Here, this R is resistance. The R is constant and it is called resistance. Okay. V is potential difference, I is electric current. Okay. Now, what is this resistance? Let us try to understand. Resistance, it is the property of a wire to oppose the flow of charge through it. When a charge is moving, some property is present in the wire that try to stop that charge, that do not allow the charge to move easily. Some substances have high resistance, some substances have low resistance. The substance that has low resistance, they are very good conductor of electricity, and the substance that has very high resistance, that completely do not allow the movement of electron or do not allow the movement of charge, that has very high resistance, they are insulator. Through them electric current cannot be moved. So resistance is the property of a conductor or wire that opposes, that try to stop the flow of current. We can say like this: suppose there is a very good pitch road, vehicle can move easily, there is less resistance. But if there is a gravel road, then it is very difficult to move the vehicle, because that gravel will create more resistance, that will do not try to move the do not allow the movement of vehicle easily. Similar fashion, different substance has different resistance. For example, copper wire has very less resistance. From copper wire, the current can easily move from one place to another place. But some, let us talk some other wire like tungsten wire, nichrome wire, they have very high resistance. It is very difficult for the charge to move from them. Okay, I hope you are understanding. Resistance is the property of a wire due to which the, the wire try to stop the flow of current through it. If resistance is less, current can move easily. Resistance is high, the current cannot move easily. I hope you understood this. This resistance, it depends upon different factor. Different material have different types of resistance. Resistance depends upon the nature of material. Resistance is also directly proportional to the length of wire. Suppose we are keeping a small wire, there is less resistance. But if we are taking a long wire, it has more resistance. Okay. Similarly, resistance is inversely proportional to the area of cross section. Area of cross section means, we can say, suppose this is wire. Okay, current is moving here. I am cutting this wire like this, then this becomes area of cross section. We can also say area of cross section indicates thickness of wire. If it is a thick wire, area of cross section will be more. If it is a thin wire, area of cross section will be less. And it has been found that if the current is flowing through the thick wire, resistance is less, and thin wire, resistance is high. It is inversely proportional to the area of cross section. Similarly, R resistance is directly proportional to the temperature. In normal wire, current is flowing nicely, but if we hit that wire, current cannot move easily through that. It means resistance, if we hit the wire, current cannot move easily. It means resistance increase with the temperature. Okay, I hope you understood this. If in a normal wire, current is flowing, but if we hit that wire, current do not flow easily through that wire, because resistance increases due to increase in temperature. R is directly proportional to temperature. Uh, the unit of resistance is ohm. The unit of resistance is ohm, and the symbol for ohm is, the ohm is also indicated like this. Let us try to define 1 ohm. What is 1 ohm? Let us try to understand. From this formula, we can write like this: R is equal to V by I. V by I. The value of R will be 1 ohm if the value of this potential difference is 1 volt and the value of electric current is 1 ampere. You know that potential difference is measured in volt and electric current is measured in ampere. From here we try to define the 1 ohm. 1 ohm is the resistance that is present in the wire if 1 ampere current is flowing and potential difference is 1 volt in that circuit. The resistance present in the wire or conductor if 1 ampere current is flowing and if 1 volt potential difference is present, the value of resistance in that wire is 1 ohm. Again, if in any circuit 1 ampere current is flowing and in this circuit there is 1 volt potential difference is present, then the resistance of this wire is 1 ohm. I hope you are understanding this. Okay. Now let us talk about the resistor. Resistor. Resistors means you can say simply the electric load. Suppose in any circuit we are keeping fan, bulb, fridge, heater. These electrical instrument that we use in the electric circuit, they are called resistors. Okay, because they consume the electrical energy and convert them into the other form of energy. That is simply we can say they are also resistance. Resistors are the resistance because they convert the electric energy into other form of energy. They do not allow the electric energy to go easily through that circuit. First they consume some of the electric energy there, so the resistors are also regarded as resistance because resistors consumes the electric energy, do not allow the electric energy to flow easily because they convert some electric energy into other form of energy. They do not allow the electric energy to move easily in that circuit. So resistors are simply the electric instrument and we can simply call it as a resistance also of the circuit. Then the resistors are combined in the circuit in two way, that is series combination of resistors and parallel combination of resistor. There are two ways through which the resistors can be combined in a circuit. Let us take example like this. Let us try to understand through the diagram. Suppose this is a cell, okay, and suppose uh, three bulb we are keeping. Suppose this is one bulb, this is another bulb, suppose this is another bulb. This bulb are connected like this in the circuit. This is the positive terminal and this is the negative terminal. This is called a series combination of resistors. If the resistors, this bulb is resistors, electric instrument, this is also resistors. If the resistors are combined in a single path, the current when moved from this negative to positive in, they follow they have only one path to move, that is this, and they are continuously connected to each other, and the only one path of current is there, that is through this only. They are serially connected, we can say. This is series combination. Let us see what is parallel combination. If this is one bulb, this is another bulb, and this is another bulb. Suppose here is a cell. Okay, we are connecting. Suppose current is going like this. We are connecting this like this. One, this is one path. This is another path, and this is another path. If we are connecting the resistors like this, it is called parallel combination of resistors. Here the current is flowing from negative to positive, then the current has different path to move. The current can go like this, tick 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 tick, here. Similarly from here, tick 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 tick. It can go like this. It can also go. The current is flowing through different path, but here the flow of current is only one path only. It has no alternative path. But here the current flows in three paths. This is called parallel combination. This is called series combination. Okay. Let us observe some properties of series combination. What happens here? Here only one switch can be kept for all three resistors. By one switch we can operate these all three. We cannot use separate switch for separate instrument. If we use here any switch for this, if we off it, if we off this bulb, the circuit will be disconnected. If we are offing this, if we try to switch off this bulb, suppose we are uh, switching off this bulb, the circuit is open, the current cannot move from here also, uh, the current cannot complete the circuit. This all the bulb will be off. What I wanted to say that we cannot use separate switch for separate instrument in the series combination. But in this case, parallel combination, we can use separate switch for separate instrument. For example, here in this, here we can use one switch here. If we are switching off this instrument and this instrument will continue to run. Then they do not become switch off. We can use separate switch for separate instrument, because if we are switching this off, only this circuit is open, but current can flow like this. This instrument we can run, this instrument also we can run. What I wanted to say, separate switch can be used for separate instrument. Which instrument we want to run? Suppose we want to run this instrument and these two instrument we want to make off. Then if we switch on this, the current will flow like this, and this can be run, and these two will be off. This and this will be off. Understanding? I hope you are understanding this. Then and here the value of current across this circuit, the value of current remains same, but the potential difference across the resistors will be different according to their capacity. Suppose its potential difference across this point V1, here suppose V2, here V3. Current will be same, potential difference will be different. But in this case, potential difference is same. Potential difference everywhere same, because from here similar potential, they are connected to the similar potential. But here the different instrument have different working capacity. They, according to their resistance, they will convert working capacity per unit charge will be different. But here a similar potential difference will go through every every resistors. Simply let us conclude, don't get confused here. Simply let us understand, series combination potential difference across the resistors will be different, and in parallel combination potential difference across all the resistors will be same. Here current will be same, for every resistors current value will be same, but here the current value will be different. Suppose this is I1, here current is using I2, here current flowing here I3. Then let us find what is the equivalent resistance of this whole circuit. Then here we can write it like this: V is equal to V1 plus V2 plus V3, and we know that V is equal to IR, and I is constant for all, so IR, and this R indicates equivalent resistance, the resistance of whole circuit. This R is indicating. This V1 means we can write I into R1, because from where we are writing this? From Ohm's law, that is V is equal to IR. We are using here V2 is equal to IR2 and V3 is equal to IR3. Here we can take I common and I can be cancelled. So R equivalent resistance is equal to IR1 plus R2 plus R3. This I we have taken common and cancelled with this. So equivalent resistance, if we have to find in the series combination, then we can find like this: what is the resistance of this, simply we will add, that is the value of equivalent resistance. But if we have to find the equivalent resistance in this parallel combination, we have to calculate like this. Here the value of I is changing, so we can write I is equal to equivalent current is equal to I1 plus I2 plus I3, and from Ohm's law, V is equal to IR, I is equal to V by R. Okay, so I, at the place of I we can write V by R E. R E represents equivalent resistance throughout the circuit, and I1 will be, V remains same here, V is same for all in the parallel combination, so V by R1 plus V by R2 plus V by R3. So here V will be common in every, and when V will be common, then our formula becomes, V will be common here and the V will be cancelled. Here we can take V common and cancel the V, so it will come like this. May I rub this? Okay. I is equal to I1 plus I2 plus I3, that is V by RE. RE indicates equivalent resistance. This is V by R1 plus V by R2 plus V by R3. Here V remains same for all, so we are keeping here V. So V by RE is equal to V common 1 by R1 plus 1 by R2 plus 1 by R3, and this V and this V can be cancelled, and 1 by RE is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is our formula to calculate the equivalent resistance across the parallel combination. Now, using this formula, we can calculate different types of numerical. The question can be given to like given to us like this. Ki, suppose 5 ohm resistance, 6 ohm resistance, 7 ohm resistance or resistors are connected in a series combination. Calculate the equivalent resistance of this circuit. Then if it is said series combination and we have to calculate the equivalent resistance, then simply equivalent resistance Re is equal to 5 plus 6 plus 7. We let this. That is the value of equivalent resistance. And sometime question can be extended to you like this. Find out the equivalent resistance. And if 5 ampere current, if 5 ampere current is flowing here, then what is the value of equivalent voltage or potential difference? What is the value of potential difference? Can question be asked. Equivalent voltage across this field. Then equivalent resistance we have calculated, and this value we have calculated. If current value is given, we can find out the overall voltage of this or overall potential difference of this circuit. For that equivalent resistance, first we need to find out by adding all the resistance. Then if current value is given, we can find the equivalent uh, potential difference. Okay, in this, if resistance, its value is given 5, 6, 7, 5 ohm, 6 ohm, 6, 7 ohm is given here. And if it is said calculate the equivalent resistance of this circuit, then equivalent resistance value is 1 by Re is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then 1 by 5, 1 by 6, 1 by 7. We will take the LCM and calculate it, and 1 by Re something value will come this side. Okay, and this, and we have to calculate Re value. So 1 by